calculate the angular momentum for a photogram record LP rotating at 33.3 revolutions per minute. And LP has a radius of 15 centimeters and a mass of 150 grams. A typical photograph can accelerate an LP from rest to its final speed of 0.35 seconds. What is the average torque would be extended on the LP. So the first thing we did was I drew just a little simple circle diagram and did 33.3 radiant revolutions per minute. And we wrote down what we had. The first thing we're finding for is angular momentum. So we have to go from revolutions divided by minutes to angular velocity radians per second. So we take the revolutions per minute, 33.3 revolutions per minute, and you're going to divide that by 2 pi rad times 1 minute divided by 60 seconds. So we have minutes cancel out, and then revolutions cancel out. And then we left with 33.3 2 pi times 2 pi divided by 60 seconds, which gives us a 3 omega equals omega of 3.48 radians per second. So first we decide so the next thing to calculate the angular momentum, we use these two formulas. We have inertia equals 1/2 mass times radius squared. Then we have angular momentum, angular velocity equals inertia times omega. So we come down here and we're using this formula. I stands for, we're going to plug this in for I. So we take 1/2 mass times radius squared times omega, and we found omega up here, which is 3.48 rad per second. And then we're going to plug in the rest of the formula. So 1/2 times 0.15 kilograms times 0.15 meters squared times 3.8 radians per second, which gives us an angular momentum of 0.0058 kilograms meters squared per second. And then that was part one of the problem. That is the angular momentum they asked us to find. And the second part, they want us to find the torque. So to find the torque of an angular momentum, you're going to take torque equals change of angular momentum divided by change in time. So L1 minus L2 divided by time, which we found L2, which is this, but L1 is at rest, so that's just 0. So we take it in, we plug it in, 0.058 kilograms meters squared per second divided by 0.35 seconds. And we get a torque equals 0.016 newtons per meters.